So let's look at rules of exponents. So most of these are going to be review. If you have a base to the first power, then that's the base. If you have a base to the 0 power, that's 1. Again, the base cannot be 0 itself. If you have a base to a power and you're multiplying it by the same base to a power, then we add the powers. If you have a base to a negative power, then that is the reciprocal. It means if it's on the top, it goes to the bottom. If it's on the bottom, it goes to the top. If you have a base to a power and you divide that by a base to a same base to a power, then you subtract the exponents, or you can think of that as just a combination of these two properties where the denominator has a negative exponent and you're adding a negative, which is the same as subtracting. If you have a base to a power and you raise that to a power, then you multiply the exponents. And if you have more than one base to a power and you raise that to a power, then you do each of those, multiply each of those exponents individually. And 2, 3, 4, however many things you're multiplying. The key here is you're multiplying inside this parenthesis. Likewise, if you have a fractional statement and you raise that fraction to a power, you multiply each exponent of the numerator and denominator individually. Okay, so those are the properties. And again, let's see, base can't be 0. Base can't be 0. The bottom can't be 0. Again, all those apply. These are old properties. So some new properties. So if you have a base to a fractional exponent, then what that's telling you is you are doing a root of that. And if it has, a fractional exponent where the numerator is not 1, then that's describing the power of the base. And sometimes that could be written as you do the root first and then the power. Sometimes if you're going to do a calculation, doing the root first and then doing the power may be easier than doing the power first and then the root. But these are new rules. But if we're just simplifying expressions, this relationship doesn't necessarily mean a whole lot if we're just trying to simplify. Let's say we wanted to simplify an expression that looks like 3 times x to the 4th, y to the 5th, all of that to the 2/3. Well, it doesn't really matter that this means the second power and the third root. We're just going to use those other properties. So our base, our 3 has an exponent of 1. So we're just going to multiply. The rule is if you have something to a power and you raise that to a power, you multiply those exponents. So we're just going to multiply each of these exponents. So x to the, this is 4 over 1, so 8/3, y to the, this is 5 over 1, 10/3. And there we go, we're done. That's it. That's all there is to simplifying that. And of course things, these expressions can get more complicated. You can have, say, x to the 2/3, y to the -4 over x to the -3, y to the 1/4, all of that raised to the 1/2. And so, again, I would just apply this exponent, multiply these exponents first. So 2/3 times 1/2 gives us 1/3. -4 times 1/2 is -2. -3 times 1/2 is -3/2. And then 1/4 times 1/2 is 1/8. Okay, now we're going to use those other properties. So I would say, well, if I have a negative exponent, I'm going to do the reciprocal. So positive exponent x to the 1/3 stays up here, but y to the second goes down the bottom because it's a negative exponent. This x to the negative 3/2 goes to the top, and y to the 1/8 stays down here. And then you're going to just use the property that says if you have the same base and you're multiplying, you add the exponent. So 1/3 plus 3/2, common denominator would be 6. So this would be 2/6 plus 9/6. Add those together. X to the 11th 6. And then 2 plus a half is 2 plus an eighth is 2 1/8, so 16, 17 eighths. And there we go. That's our answer. So, you know, these properties of exponents just apply like they have in the past. The fact that they're fractions, that may complicate the math a little bit. Hopefully you have a calculator that can do fractions for you, so you don't have to do a bunch of this work yourself. But the process, the rules that we're going to use are going to be the same. Now, let's say we were looking at more advanced things here. So this may not be what we're going to get into, but just so you can kind of, if you're interested and you want to know, well, why are we doing this? Why are we wasting our time with it? Let's say I needed to take the cube root of the square root of x to the 5th. And say, what is that? Well, you know, turning these to fractional exponents, what this looks like is the square root is a half, and the cube root is a third. And so the rule is if you have an exponent to an exponent, you multiply. So this is 5 over 1. So this is x to the 5/2 to the 1/3. And again, 5/2 times 1/3, x to the 5/6. And so if you wanted to turn it back to root notation, what is this telling me? This says I have the 6th root of x to the 5th. And that's an easier way to simplify it. There are times in higher level math that, like, you know, if you were going to do some calculus, there's a rule here that if you have a function, let's say you had x to the 6, then this thing called the derivative, which, oops, that's not right, not the inverse, the derivative. The derivative is basically an equation that describes how the slope of this graph changes over time. And it would look like this. And so you can kind of, this is a real simple type of derivative. What you can see is you take the exponent down there and you decrease it by a power of 1. Well, you could imagine if I had something like the 3rd root of x to the 5th, and I wanted to take its derivative. Well, if I wanted to use this rule here, then I would want to write this as a single exponent, 5/3 exponent. And then I could do the derivative of this, and what would happen is this 5/3 would come down, and then this exponent would decrease by 1. So if you decrease that by 1, that's the same as 3 over 3. That'd give you 2/3. So what's the derivative of this? The derivative is 5/3 times the cube root of x squared. That's the derivative. So that's a use for it. Obviously, we're not going to do that in this algebra course, but you know, you can kind of see where this comes into play. Some people may feel like, you know, if we're going to use root notation, why bother with this fraction notation? The question really should be, if we have fraction notation, why waste our time with the root notation? And just out of convenience more than anything. So there's a little introduction to rules of exponents using root.